Again, the first step requires us to find or create a function. If we don't have a function, then we cannot not go through the steps. So step number 1, I write that x minus 2 squared minus natural log x equals 0. I determine that the function is x minus 2 squared minus natural log x. And in step number 3, I say that the function is continuous for x greater than 0. This is continuous everywhere, but this is defined only to the right of 0. So careful with that. Number 4, I have to find an interval. So in the graphing calculator, I clear and I put in parentheses x minus 2 squared and then minus natural log x. And I start not at 0 but to the right of 0, so with second and table. Of course I have error anywhere to the left of 0 or 0. So let's say 1, 2, good enough. So I found that f of 1 is positive and f of 2 is negative. So therefore, by IVT, there exists an R in the open interval 1, 2 such that f of R is 0. So therefore, I'm ready to choose an x0 and write Newton. Sx minus the function at the top, the derivative in the denominator. Make sure that whatever I start with, it's not 0 in the denominator. So if I start with 1, 1 minus 2 is negative 1, so this will be negative 2 minus 1. It's not 0. If I start with 2, this is 0 and this is 1/2. It doesn't matter. So the denominator is safe. It's not 0. So we are ready to start with whatever you want. Let's start with 1. It doesn't matter. However, I have to say that if I started at negative 1, maybe the method would converge in 3 steps, not in 4. But it's not a big difference, not a big deal. Okay, so now careful how we plug this function in. So in y equals, don't delete, just insert. I'm inserting an x and a minus and put parentheses around the top. Left parenthesis and right parenthesis, and then divide with parentheses. You can write 2x minus 4 if it's easier for you, and then minus 1 divided by x, and close the parenthesis for the denominator. So 2x minus 4 minus 1 over x. So now we go to second and table. I'm sorry, I don't need to do that. So go to variables. Go to y equals function, call function 1, and in parentheses, we are going to start with the first one is 1, and press enter. And this will be our x1. x1 is 1.333333, good enough. Now, the next step, I want to override 1 and replace it with the previous answer. And from that moment on, I can just copy that. So x sub 2 will be 1.408579272. The next will be 1.412381564. The next one, we haven't decided how many decimal digits. I'm assuming 6. 412391172, and this should be more than enough. It's the same. So then 246. So we determined the solution or the zero of this function with 6 digits accuracy. Any questions? Anyone? Any questions? Is there anything else you would like to work on?
I think I'm pretty good for now.
Any questions? Mason, anything?
Oh, yeah, so, sorry, I was just trying to put the roll in that, but I guess just thinking for the test on
Yes.
Monday,
Yes.
just kind of like part B of number 1 on the practice test.
Yes.
So, kind of when you're doing it says tan into the third parentheses sine x.
So can you give me the problem?
Oh, yeah, it's fx equals tan to the third parentheses sine x.
Like this? Is it x to the third?
Oh, no, just tan to the third.
Okay.
And then parentheses sine x.
Yes.
Kind of how would you almost start approaching that?
Well, so what are we asked to do? Let me see. I have WebAssign open, so let me take a look. So this is from the pre-test.
This is from the test 2 that you gave us.
Oh. So
Yeah,
what is
yeah.
it? Oh, I'm sorry. What is the question asking us to do? Let me take a look. I mean, I don't remember
No,
what.
it's just differentiating.
Is it 10 to the third times sine x?
Mhm.
Maybe I missed something. Let me take a look. If I see it, maybe I remember, maybe I have something else in there. How come that we didn't discuss that before? Let's take a look.
Well, no, because I don't know. I thought we had already went over it, but then I guess I don't know. I couldn't find it.
Yeah, let's take a look. I mean, maybe we didn't. Is it a limit? Is it? Oh, it's x to sine x.
Wait, what?
So you're talking about what I emailed you?
Yep.
But what I have is x raised to sine x.
I have.
Can you show me? So let me show you what I have in that symbol. I have x raised to sine x.
Oh no, the one right below it.
Oh, below it. Oh, sorry.
For B.
Oh, you said tangent. I wrote 10. That's why I didn't know what. Okay, you said tangent. Okay, I'm so sorry. Sorry.
Yeah, you're good.
My apologies. So when we talk about so f of x equals tangent to the third of sine x.
Yeah.
So remember, this is the first function, this is the second function, and this is the third function. So when I differentiate, first I have to differentiate the power, which means 3 times tangent squared of sine x. Tangent is applied to sine x. That's the argument of tangent. Now I have to differentiate tangent, which is secant squared, of the argument, and then times I differentiate the inner function, which is cosine x. So, yes?
Oh, what was that?
Go ahead. So
So if you do that, do you simplify even further?
you can't. They're all products. No, you can't. So remember, tangent does not exist. Tangent of x exists, or tangent of sine x exists. So tangent has to have an argument. So this is like this. So tangent is applied to sine. So first you have to differentiate the power. 3 times this squared times this prime of sine x times this prime, which is cosine x. So you cannot do anything else.
Okay, so we're okay with just leaving it.
Yes, you have to.
Perfect. Okay. No, that's the only thing I was confused on.
Yes, no, there is nothing you can do there. This is it.
Perfect.
Anything else you would like to go over?
I'm honestly good.
Okay, so I'm going to send everyone an email